Hey guys, we are on to 6.4b, applications of systems of linear equations, applications being like some word problems. But part one, there's two parts to this. Our objective is to create and solve systems of equations. I'm going to be talking about two kind of different parts, something called a break-even point, and then what a viable solution will be. So there's a bunch of different types of problems that use a linear equation or linear systems. I cannot go over all of them. So I'm going to focus on break-even points, wind or current problems, water current, and then coin problems. All right, that's going to be the focus of the next two videos, actually. But let's talk business, okay? Because this is probably the most applicable thing right here. Businesses, their main goal is to make money. They make money when their income, the amount they take in, is more than their expenses, the amount they have to pay. All right. And that point, when that happens, when their income surpasses their expenses, that's called the break even point. All right. The break even point, this is the point all businesses are striving to get to. This is when the income equals the expenses of a business. This is kind of what it looks like graphically. All right. If you look, we kind of have a system right here. The blue line represents the income, the red line represents the expenses, and that black dot right here, this is where they are the same. Everywhere before that black dot, the blue line is below the red line, meaning they are not making money, meaning they're taking income, but their expenses are more. And then after, to the right of that dot, the blue line is above, meaning they are making money. They are earning a profit. All right. So the break even point is when the point is when the income equals the expenses. So let's find one of these break-even points. There's this fashion designer that they design and sell hats. Material for each hat costs $5.50, and the hat sells for $12.50. Right away, you're like, oh, there's a $7 difference. Perfect, but that's something we'll kind of figure out later. The designer also spends $1,400 in advertising. How many hats must the designer sell to break even? All right. So we're going to need to create a system for this. We need two different equations. And what we always want to do is define our variable, saying my y is going to equal this and my x is going to equal that. So in this case, y is going to be my total amount of money and x will be my total number of hats. I'm going to give you the equation for income. The income is y equals 1250x. The total money they make is 1250 times the number of hats. That's the only income that this designer gets. What's the equation going to be for the expenses? Hopefully you came up with y equals $1,400 expenses for the advertising plus the 550 times x, the 550 per the hat that they have to buy the material for. Now, what method do you think we should use in seeing this system? If you didn't say substitution, okay, I think we should use substitution. If you got it wrong, so what? But substitution, I think we should use. I'm going to set the two expressions equal to each other. The income, 1250, will equal the 1400 plus 550x because that's going to give me the break-even point when the x's are the same, when the number of hats are the same. I'm going to take away 550 from each side. That leaves me with 7x equals 1400. Now, since 7 is my coefficient, I'm going to divide by 7, divide it out, and I get x equals 200. So 200 hats. Once this person sells 200 hats, that is the break-even point. Bonus question. If they sell 201 hats, what's their profit? Sometimes we're going to need to consider constraints. Constraints means like there's a window of numbers that will actually only work. All right. Certain numbers are going to be too big or too small, can't have decimals, can't have fractions. So those are going to be constraints. Also, when we solve a problem like our next one, we need to consider the viability of the solution, meaning if we get an answer for hours and that answer is negative, that doesn't make any sense. We can't have a negative form of time and it makes sense in a situation. All right. That answer would be not viable. All right. So let's actually go through a problem with this. A local zoo is filling up water tanks for elephants. Yay. The first tank has 50 gallons in it already, and it's filling up at 10 gallons per hour. The second tank has 29 gallons, and that one's filling up at 3 gallons per hour. When will the two tanks have the same amount of water? Explain. Your explanation should be your work. If you want to explain it in sentences and paragraphs, more power to you, but this is math class. Similar last problem, we want to identify our two variables. Define y will be the amount of water, and x will be the amount of time. What would be a viable solution here? All right, choose from the list. What would be viable to you? All right, now let's create our system. The first tank, y equals 50 plus 10x. The second tank, y equals 29 plus 3x. What method do you think we should use here? I again think we should use substitution. A lot of times it's going to be set up for substitution in these application style problems. What I'm going to do is I'm going to set the two expressions equal to each other. The first tank, 50 plus 10x, equals the second tank, 29 plus 3x. When they are equal, that'll be the same number of time when those two x's are the same. So now let's isolate one of the variables. I'm going to subtract 3x from both sides just because it'll leave me with a positive 7x. Now what I have to do is subtract away 50. And now I'm left with 7x equals negative 21. Uh-oh. What do you think this big Al Bundy uh-oh is for? Well, once we divide by 7, we get x equals negative 3. We can't have negative time. So that means there's no viable solution for this problem. Technically, it's no solution to this problem because it's a real world problem, but we don't say no solution. It's no viable solution because there is a solution mathematically to this. It's negative 3 for the time, but negative 3 for the time does not make any sense in context. So again, we say it's no viable solution. Okay, that's it for this video. What you can do now is watch the second part of this, and the work will follow up combining all of that. All right.